Hi, I'm Dr. Barbara Pappas. I'm here today with Dr. Yiying Wu, professor in the Inorganic Division of the Chemistry and Biochemistry Department at Ohio State. And today we're going to talk about solar and battery energy. Well, thank you, Dr. Wu, for spending time with us today.
My pleasure.
We're going to be talking about two kinds of energy that you care very much about. The first one is the world's greatest source of energy, largely untapped, solar. And I was hoping that you could tell us a little bit about the basic workings of a solar cell, a photoelectric cell.
Of course. So solar cells are typically made of semiconductors. And without going into the details, so basically is that sunlight we can treat as a stream of photons, and photons can excite electrons in the semiconductor. So it's like a pump, so that you can pump the electrons from one side, go through the external circuit, do the work, and then come back. So that's basically a very a simplified view of the solar cells.
Very good. Yeah. Where would students come in contact with solar cells?
Right now, I mean, probably very typically is some of the calculators.
Yeah, that's what I think of too. And so I pulled one apart, and this is the solar cell right there, is it not?
Yeah, that's right. So normally, this is a nice view. Is that so? Right now here, this is more like a coin's battery. So you can see that because this is a nice way to show the challenge of battery of solar cell is that because sunlight is always in and day in day out, etc. So if you only have the solar cell, it does not have the mechanism to store the energy. So that's the reason you have a front solar panel.
Yep.
And then backside you have this is a coin cell to store the energy.
Oh, I see. I'm sorry. I thought that was the solar cell. The solar cell is this part.
That's right.
And then you have all those wires having to connect to a battery.
So that's a coin cell battery.
Oh, we'll get to that in a minute. Could you tell me what the advantages are to solar cells?
Oh, I mean, apparently it's clean, right?
Yeah.
So right now, our lifestyle is based on the fossil fuels, and environment definitely is one issue. And another thing is one day we're going to use all of them. Available reserve. So, but we have the huge nuclear fusion reactor in the sky.
Yeah.
So why not? So that is definitely the major advantage. I mean, it's clean, renewable, and it can last. I don't know how long.
Endless. Yeah. Seriously.
Basically.
Yeah. If the sun goes out, we're going to go out anyway. So.
Well, hopefully, we can develop. The technology in Star Wars, so we can travel
that's
around.
Right. I forgot about that. Yeah. And what are some of the disadvantages or the challenges of a solar cell usage?
Yeah. So basically, the main thing is it's quite a diffusive energy source. So I mean, basically, every 1 square centimeter. The energy flux is about 100 milliwatt. I mean, I can double check the number, but so that means it's not dense, it's a distribute. So that gives us that how we need to cover a pretty large area so that provide enough electricity. So that is one. Another is what I just mentioned is that the sunlight is not constant. So day in, day out. So then, and that does not match our demand very well.
Yeah.
Because, for example, when we go back home at 6 o'clock, then we turn on the TV, etc. So 6 o'clock, 8 o'clock in the evening probably is the highest peak for electricity. But we know that sun.
There's no sun there. Not in Columbus, Ohio.
Exactly. So that is really the big challenge: is how do we match the demand, and also is how to maintain this kind of the constant supply through.
Beautiful. So let's move right into then batteries. very briefly, could you describe the function or the basic device that we call battery?
So battery, it's a device that converts the chemical energy into electricity.
Yeah.
So typically it's based on the redox reaction.
Yep. And where would students encounter batteries? Why are batteries so important to us? I think you've touched a little bit on it. The fact that we have to have energy at our fingertips and
yes, absolutely. So right now, consumer electronics. Just imagine iPad, iPhone.
Oh yes.
Whatever.
Yeah,
you open it, you basically, that is what you need for, and we always want a longer and longer time.
Yes. That I know that that's one of the problems with getting an all-electric vehicle, because people are afraid it's going to run out of juice.
Exactly.
They're going to be 50 miles away from home, and
exactly. So transportation is another emerging application.
My understanding is that the last big breakthrough in battery technology, I mean, like the lead storage battery is 150 years old, the one that we're typically see in our cars. The last big breakthrough was the lithium-ion battery, and that has been responsible for the iPads and all the wonderful things. Exactly. Could you discuss that a little bit, and then what the emerging technology is?
Sure. I mean, so lithium-ion battery was introduced by Sony back in 1991.
Okay.
It's called lithium-ion. Is that, I mean, first we can start with lithium. Why we are so obsessed with lithium? Look at the periodic table. That's the lightest metal. Yeah. So then because we want to carry more energy in specific volume and weight, so it's natural to go with the lighter elements. And that is in fact related to, I mean, the future, when people are trying to go beyond the lithium-ion batteries, what can be the new technologies. So now if you analyze the lithium-ion batteries, that on one side we use carbon to store lithium ions. Carbon is already very light, so that's not pretty nice. It's already very good. But on the other side, then typically we use transition metal based oxides or phosphate, for example. So then they are much heavier, right? Yeah. So then if you want to make it even more energy dense, then a natural thing is to get rid of those heavier components.
I see.
So that's the reason, like when we talk about beyond lithium ion, so like air-based batteries, like metal air. It's like, for example, care we are doing that.
Yes.
And also like sulfur, because both of them is like trying to replace those kind of heavier by oxygen.
I didn't know that.
And by sulfur.
Great. Fabulous, yeah.
So that's exactly the motivation for that.
Could you talk a little bit about the K-Air battery from your group?
Yeah, so first I want to say is that the idea was generated when I was teaching general chemistry.
Oh, wonderful.
Yeah. So because, I mean, maybe a little bit into detail is that because whenever you try to use oxygen in electrochemistry, so first is a reduction reaction. And when you use in fuel cells or in many other metal air batteries, it is a multi-electron process. It's like, just imagine like a fuel cell is that you start with O2 molecule and then you go all the way to water.
Yeah.
So for each O2 molecule, we need 4 electrons to reduce.
Yeah.
So when this kind of multi-electron process, then you need a pretty expensive electrocatalyst to catalyze this kind of reduction reaction to make it faster and at a low over potential. So then when I was teaching Gen Chem, we know, like, although alkaline metals are similar, but when you go from lithium, sodium, and potassium, they have different properties when they react with oxygen. Right? And the potassium react oxygen from potassium superoxide. And if you look at the O2 molecule and superoxide ion, it's a 1 electron process.
Oh, okay. Yes.
Yeah?
All right.
So electrochemists like 1 electron because it makes it reversible. And
Oh, wow. Yes. Okay.
very little structure change. So that it comes down to the idea is that can we just use potassium? So initially it's like, isn't this like straightforward? To go lithium, put potassium, what big deal? But the big deal is we don't need any electrocatalyst. Then we can just utilize a reversible single electron process.
Oh, gosh.
So that
Okay.
is the fundamental difference.
Wonderful, yes. And I've heard you call it a breathing battery that breathes in and out because it intakes air
Yes.
and then converts the O2 using the single electron process to the, does it go to the superoxide in this?
Yes.
Okay.
So we just deposit potassium superoxide
Okay.
at the air electrolyte.
And why does it breathe out again then?
So that is when you want to charge it.
Oh, sure.
Yeah, they are all rechargeable, right?
And you've been able to recharge it hundreds and hundreds of, on the scale of a lithium battery, right?
Yeah, for lithium-ion battery.
Lithium-ion,
Yeah, so then they can charge like thousands of cycles.
Yes.
Because you think about like when you buy a car, you want like 10 years
Yeah.
life
Yeah.
at least, and that give you like if you need to charge it every day, that
Yes.
give us 3,600 cycles,
Yeah.
right? So that's a typical requirement.
And the lithium ion, I remember when it used to get so hot upon recharging that it would, their laptops would burst into flames.
Oh,
Do
yeah.
you remember that? That was about 10 years ago. That was exciting. Yeah, so you have to have it be a safe
Yes.
type of recharging also.
That's right.
And discharging, of
That's
course.
right.
Yeah.
Yeah.
And then this is the fabulous breakthrough that you and your group have done is couple the solar cell with a battery.
Yes.
And I'd love if you could discuss that some too, please.
Absolutely. So this is like a typical example is the platform that people normally use is I have a solar panel and a coin cell separately, right?
A battery separate,
A
yeah.
battery separately.
Yeah.
Yes. So now what we so what we are thinking is that can we just integrate the two devices into a single device? So there's many benefits. One is many of the costs are from the materials and from
Yeah.
the sealing and the framework. So by integrating together, we basically are saving the expense from one device because you need
The
to
fabrication
consider
costs are less,
Yes,
much
exactly.
less, yes.
Much less, exactly. And the cost, in fact, is the reason that the penetration of renewable energy is limited.
Yes.
So once you reduce the cost, and the cost, in fact, is mainly determined by the battery. It's not by the solar panel. Solar panel has been developed so well, so the cost is not an issue anymore.
I see. Okay.
But battery is still difficult to reduce the cost.
Yep. Yeah.
So that is one motivation. And another is also from the science point of view is that solar cell, many aspects based on the photochemistry and the photoelectric chemistry. And the battery is based on this redox electrochemistry. So what we are trying to do is that sometimes scientists, they work in small community.
Yeah.
They don't talk each other very much. You can see many examples in the history. And so, but my group has a kind of unique position is that I have like two projects, and sometimes they just separate into two subgroups. Okay. So one subgroup we're working on the solar cells, and another subgroup we're working on batteries.
Oh.
And I thought, can we just
Maybe
work
these guys
together?
should talk to each other.
Exactly.
Yeah.
So we're trying to merge them together so that we really want to try to introduce the photochemistry and photoelectric chemistry into the battery so that they can really, because many things they can help each other. It's not just
I see. One isn't just tagged on as an afterthought. They're actually supporting each other.
Exactly.
I see.
Exactly. One good example is like a thermal management. Battery is difficult to work at low temperature because they kind of worry about the freezing of those kind of like electrolyte. Solar cell love low temperature. because when you low temperature, you freeze many of the for example vibration modes. It can make the carriers the lifetimes longer.
I see.
Solar cell is fine at low temperature, but when you increase the temperature, the efficiency just goes down.
Okay.
So now you can put them together, you can kind of manage them. Is that one can help that to cool down, the other one can help to heat up. It can provide a kind of synergistic effect. So this is just one example, but many other things is that we can you can try to help each other.
Yeah.
So that also provides another part of the picture is So.
Oh, and I know that your group has won numerous competitions for this, including the DOE's Clean Energy Award. So things are just going to start exploding around here. So that's wonderful, though. And I like also too when they talk about the works done, there are graduate students responsible for some of the most exciting innovations.
Absolutely.
So
they are the co-inventors. So
yes, that's fabulous.
And also. They are not just, so I think make them different is they all now have the opportunity to be the entrepreneur.
Yes,
not just a researcher.
Yes.
So.
Well, without gushing too much, I think it's because you are such a fantastic PI for them. So.
It's always together is that the fun part of this job is have good graduate students. So it's always so happy.
Yeah.
It's also like what I mentioned is the
synergy.
Yeah, synergy.
Definitely. All right. Well, thank you so much for your time today. I know how busy you are, so I appreciate it.